Okay, we're in section 117, contents, examples, exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra. You're looking at a PDF document. This PDF is being made available to the Prison Mathematics Project participants. I realize that other people may be looking at these videos and are interested in the document. Reach out to me and I'll let you know what's going to get published. Let me get back to this. I'm sorry about that. My email address is Bannon. That's B, the @ symbol, NNON.US. All right? What's the expectation? You read through this. It's a tough read. We want you to read through it, try to make some sense out of it. So I'm going to claim over here, kind of reading through it. They talk about, there's a theory of equations. And what I want to do is I try to summarize things for you. But the bottom line is I want to start doing examples. And again, the expectation is you've read through it and you're ready to have someone walk you through the examples now. So I'm going to say that over here, I notice this is a 4th degree polynomial right here. Right, so someone says, if it's a 4th degree polynomial, you know what, I'm making a mistake here. Let me back up. Let me get my highlighter out. Sorry about that. That's a 4th degree polynomial. I know there's going to be 4 solutions to it. Now, they're telling me that there's 2 solutions to the problem. And the solutions are going to be 2 and minus 5/3. Now, by the way, if you're doubting Thomas, you can check it out. Now, what I mean by that, you could write this over here. I'll put down what I mean by that. And it's good to doubt. It's really good to doubt. So they're saying, if I plug a 2 in, I'd get to 0. I'm just writing down what they're saying. I'll put a question there. I'm doubting Thomas. So what do you get? Well, 2 to the 4th is 2 times 4, 8, 16. So it's 9 times 16. 9 times 16 is going to be 90 and 54, 144. And then 37 times 2 squared is 4, right? That's 120 and 28, 148. Minus 16 plus 20 equals 0. Well, I'm going to put these two together. That's going to be 168. I'm sorry, I made a mistake there. I gotta back up. I got 8s on my brain. 144 plus 20 is 164. Minus 148 minus 16 is minus, 158, 164. This works out beautiful. I got that one. This is done. Now, again, I'm a doubting Thomas. It's a lot of work, but I'm going to put it down for you. I'm going to write this over here, 9. By the way, this question mark gets removed now. I know it's equal. Let's do the next one. 9 minus 5/3 square is 4th power. That's crazy. That's a lot of work. Minus 37. Then it's going to be minus 5/3. Whoops. Getting excited there. Squared. Minus 8 times minus 5/3. Plus 20 equals 0. I got some work to do here. And it's not easy work. But I do notice the first guy here, right? Again, it's not easy to do. It's going to be 25 times 25. I see that. I'll write this over to the side for you. Oh, by the way, it's a question mark. I don't know if it's true. I'm doubting Thomas. So what do you get? Well, 20 times 25 is going to be 500. And 5 times 25 is 125. So what do I get? I get 625. Let me write this over here. I just did the minus 5 to the 4th power. Now I see 3 to the 4th, but 9 is 3 squared. Right, so I get 3 squared in the bottom, which is 9. Let me keep going. What do you get over here? Well, 25 times 37. I'll write that down for you. The bottom is 9, though. That's pretty simple. All right, now I'm going to do 37 times 25. Let's go through it. 7 times 25, right? That's 175. And 3 times 25 is 75, so 750. So what do you get? You get, let's write this down. Be really careful. 5, that's 12, 9. All right, let's keep going. What do you get next? Plus, well, that's going to be 40 thirds, isn't it? But I want to write in terms of ninths. Let's go 120 ninths. And then this guy's going to be, 20 is going to be 180 over 9. And again, they're saying it's equal to 0, but I don't know. Maybe that's not equal to 0. Let's take a look at it. 625 minus 925 is going to be minus 300 over 9. And 120 plus 180 is 300 over 9. So it does equal 0. So, you know, I don't mind verifying things, but, you know, maybe I should just trust them. But I just verified those. Both of those are really good answers to the problem. And someone said, is that important to know? Yeah, but I guess I should have just trusted them. Now, what am I saying over here? I'm saying that these are roots. Oops, sorry about that. I did it again. Both of these are roots. So what I want to do is I want to write down, if they're roots, I know the factors. Let's write this down. So 9x to the 4th power minus 37x squared minus 8x plus 20 is equal to, well, I know if 2 is a root, a factor would be x minus 2. And why is that? Well, I'll write that down. If x equals 2, subtract 2 from both sides, and you would get x equals minus 2. I'm going to write the other one down. Now, what's the other one going to be? It's right over here, and that would be x plus 5 thirds is equal to 0. Now, a lot of students are creeped out by the fraction. Multiply both sides by 3. What would you get? 3x plus 5. Here's my problem. I don't know what's over there. All right? Now, certainly, I know there's 4 solutions to the problem. I just don't know what they are. But they gave me 2, and, you know, I said, good for them. So what I'm going to do, I'll do the division. For me to do the division, though, I want to multiply this out. And what is this going to give me? 3x squared. And let's see, you get 5x minus 6x, which is minus x. And then you get minus 10. Now, if you make a mistake, you're not going to get the remainder of 0. But what I want to do is I want to do the division now. So it's going to be 3x squared minus x minus 10 is being divided into 9x4 minus 37x squared minus 8x plus 20. And let's go to town. So what do you got? I'm going to say 3x squared. Again, if things go well, I'll get a remainder of 0. If they're not going well, I've done something wrong. That's going to be 9x4 minus, let's see, 3x cubed, right? And then it's going to be what? Plus, not my plus, minus 30x squared. That's pretty tough. Let's do our subtraction. So what do you get? 3x cubed. Let's see, minus 37 plus 30 is minus 7x squared minus 8x plus 20. Let's repeat. What are you going to do now? I guess we'd put plus x down, right? What does that give me? 3x cubed. Remember, if this doesn't give me a remainder of 0, I've done something wrong. Minus x squared minus 10x. And I do make mistakes. So what do you get over here? Well, if I did that, you would get minus 6x squared. Let's see, plus 2x plus 20. I'm going to repeat. Minus 2. What do you get? Well, you get minus 6x squared. Minus 2 times x is plus 2x. And minus 2 times 10, minus 10 is going to be plus 20. So yeah, I get a remainder of 0. So now I found the missing factor. And let me write that down for you. Just give me a second to do so. And I'm going to erase this over here. I'm done with that. And I'm going to write down the missing factor now. And I just found it by division. What I find? 3x squared plus x minus 2. Now, certainly when I do that, I want to claim to you, my goal is to find all the roots. So I'm left with a problem now. And the problem I'm left with is 3x squared plus x minus 2 is equal to 0. And someone said, can you factor that? And, you know, what I would claim is you try. And if you can't get it, you have to use quadratic formula. I want to point out I put the division down for you over here if you want to take a look at that. It may look different the way I do division, but typically that's what a lot of students will do, all right? They do that division thing. Boy, I got to do this now. And let me just give it, like, I can't give it many shots, but I'll put this over here. 3x and x. And what would I get over there? I guess I'd use 2 and 1, right? And I'm going to say, I don't know, minus 2 plus 1. Let me see if that works. What do you get? You get 3x squared. That looks beautiful. You get 3x minus 2x. That's x. Oh, that worked beautifully. So what do you get over here? You get another root. What's that root going to be? That root would be 2/3. And the other root would be x equals minus 1. I found all 4 roots, and I got it factored. I want to point out what I mean by that. If you go up here, and someone said, what's the factorization of this? I'll write this down for you. The factorization of this problem over here, we'll check the key later, is going to be x minus 2, 3x plus 5, let's see, x plus 1, and the other is going to be 3x minus 2. This is the factorization. What are the roots? Again, this is the factorization. This is we factored. The roots are, unless I made a mistake, the roots they gave me, which is 2 minus 5/3. We've already verified that. And the other roots we found were minus 1 and 2/3. Right, found all 4 roots. Let's look at our key and see if I've done that. I think I've done the factoring, right? Let's just take a look. Yep, 3x plus 5, 3x minus 2, yep, and x plus 1. Right? Okay, let's go for graph. I know I give you the graph, but I really have to say this. You don't need to be given the graph. You can start to construct your own graphs over here. So when I'm graphing out, what I want to point out, we're graphing a function, this function over here. One of the most easy points to get is the y-intercept. How do you do that? Set y equal to 0. And what would you get? 20 for the x. I'm sorry. I made a mistake. I always say I'm daydreaming. I'm not daydreaming. I'm just not thinking. So set x equal to 0. When you do that, what would you get? Well, when x is 0, you just get 20. I want to point out that point's right over here. Everyone should be able to get that point. It's a simple point, low-hanging fruit. Right? The other points we can get are going to be those roots. What are the roots? It's where the function takes on its 0, where f of x equals 0. But where does f of x equal 0? When the roots become 0. I'm sorry, when the factors become 0. So at minus 1, let's see, at 2, I'm doing the easy one first. This one over here, let's see, 3x minus 2, that would be 2/3, right? 2/3 is right here. I'll write these points down for you, by the way. This point over here is 4, 0. This point over here is going to be 2/3, 0. And it even looks like 2/3. What's this point over here? Well, that was the minus 1, 0. We did that before. And this point over here, I'm going to be looking at this guy over here. What would that be? Give you minus, I'll write this over here, minus 5/3. That's certainly about minus 5/3 over there. Now, so it says, how could you connect the dots together? And all I can say is that if you know the roots, all you have to do is look at the signs. I'm going to put this down for you. Minus 5/3. That's a 0. I put a circle on it. Minus 1. Put a circle on it. 2/3. I'll put a circle on it. And the other one's going to be 4. All you have to do is pick a value on those intervals. How many intervals do you have? I want to outline this. You have 1, 2, 3, 4, 5 intervals to test out. I like to go one at a time. And what I mean by that, I'm going to pick a number between minus 1 and 2/3 and plug in a 0. When you plug it in, you're going to plug it in here. But you're not looking for the number. You're only looking for the sign. Let's go for it. What do you get if you plug 0 in? So my test point 0. And write this down for it. Test point. My pen is running low. Give me a sec. I got to sharpen it up. Whoops. And I'm going to try 0, right? I'll put this down for you. Test point. X equals 0. Again, we're plugging it in here because it's really easy to do. All right, what do you get? You would get a negative number. That's the first factor. Second factor would be a positive number. Third factor would be a negative number. Fourth factor would be positive number. You know something you don't know what the number is? It's one of the sign. What's the overall sign there? Positive. By the way, That's no surprise. I'm seeing it. It's positive. By the way, I may not know the connection. How did I know it was positive? I already had a test point over there. It turned out to be 20. All right, let me take another look at a test point. And I know it's difficult, but I want to get a good test point between 2/3 and 4. And I'm going to say the number 1. So I'm going to take the test point, x equals 1. Whoops, test point, x equals 1. Let's plug it in. Oh, by the way, I notice I have an artifact there that's not correct. I didn't want the number, I just said the sign. Okay, what are we doing? We're doing 1. First factor, minus. Second factor, positive. Third factor would be 3 minus 2, which is positive. Fourth factor, positive. Overall, what do you have? Negative. This is all negative here. What does it mean? My curve's got to be below the x-axis. All right, let's take a test point over here now. I'm going to say 5 is a good test point. Plug it in. First factor, positive. Second factor, positive. Third factor, positive. Fourth factor is positive. Everything is positive. What do I know? It's positive. I hope you also know that this thing is a fourth degree polynomial, and as the numbers get large, it's going to grow very rapidly. All right? Let's take another value test point. I know it's difficult. I'm going to go over here, and I'm picking a number between -1 and -5/3. Some students have trouble with this, by the way. You should realize that -5/3, 3 goes into 5 once, it's 1 2/3. So I'm going to say a number like -1.1 would be a really good test point there. Let me go back up here. I'll write that down for you. Test point. I'm going to take x to be -1.1. Again, we're plugging it in here. What do you get? You get a negative. Well, 3 times -1.1 is -3.3 plus 5. That's positive. Well, -3 times -1.1 is -3.3, and -2 is a negative number. And -1.1 plus 1 is also a negative number. What do you get over there? Well, negative times a positive times a negative times a negative is going to be a negative. So what do I know? I know it's negative in this region. Let's connect it up with the negative thing. And that looks negative to me, right? Let's go over here. What's a good test point over there? I would say -2. Let me write that down for you. X equals -2. Plug it in. Again, we're plugging it into the factored form because it's so much easier. What do you get? Negative on the first factor. Second factor would be negative. Third factor would be negative. And the fourth factor is negative. What's a negative times a negative times a negative times a negative? It's positive. I'll write that over here for you. What does that mean? It's above the x-axis here. Now, someone says, how do you know it's going up? Well, look at it. It's a fourth degree polynomial. When you're kind of, putting a negative number in fourth degree, it gets huge quick. It overpowers everything else in the problem. All right? That's a good-looking picture. And I'm going to say I'm done with that. All right? Someone says, a lot of work. Yeah, it is a lot of work. Get the exercises. This is where all your work is going to come into play, by the way. What's exercises? That's where you get a chance to try things out on your own. So really the same thing. You're given this and you're given a root. I recommend you do long division to find out the other roots of the problem, by the way. You can also look at a graph. I put a graph down there for you. What's the point of that? Well, before you do that, I want to point out you could basically construct a graph. Let me point out what I mean by that. The y-intercept would be 60. I'll put this over here. What are the roots? -6. I'll put that over here. It's a rough sketch, by the way. 2. And what was the other root? Oh, 5. Over here somewhere. What are you going to do? Sign analysis. And I want to point out what I mean by that. This thing factors. I'll write this down. X minus 5. Again, you haven't done the work yet. When you do the work, you'll find this. It's all written down for you, but you need to do the work yourself. Now you're going to sign analysis. What's a good number after 5? I don't know, 10. Plug it in, plus, plus, plus. All right, I'll put this over here. I'm going to take a number below -6, like -7. What would you get? And again, I'm just talking through it. This is something you need to be doing on your own. If I took -7 into the factors, I'd get minus, minus, minus. That would be negative. I'm getting this over there. Now, what do I notice between the -6 and 2? I have a test point, and I got to be honest with you, I don't know how exactly it looks, but I'm going to say maybe something like this over here. Now, between 2 and 5, what's a good test point? I'd say 3. Plug it in. What do you get? Negative, positive. I know I'm going quick. Positive. What's that? Negative. So I'll say something like over here. Now granted, we're going to give you a much better picture. What does that mean? You're going to look at the picture. This is something that I would say is a pre-calc sketch. Pre-calc. It's something that Wells would do, all right? Wells didn't have the tools I had. Let's take a look at the picture. It's a much better picture. Much better, all right? Much better. You notice my picture really doesn't represent properly what the thing looks like here or what it looks like over here. But it certainly has the general shape of it. There's no doubt about that. The general shape is there, all right? You do this for all the problems, by the way. It's work. It's a lot of work. What do? This is a cubic. It'll have 3 roots. They give you 1. You're going to use a division to find a depressed quadratic, and that depressed quadratic is going to be nice and easy to factor. This over here, it's a 3rd degree polynomial. They give you one of the roots. I want to point out what they're saying is x equals minus 1/2 will produce a 0. I would solve this by multiplying both sides by 2, and the factor would be x plus 1. What am I claiming over here? 2x plus 1, and then you got to find out the missing quadratic. This would be quadratic. How do you find that? You divide it into this thing over here. And again, you get a rough picture. All the work is down there, including the division. You can do that. Cubic, again, let me repeat this. X equals 4/3. We're claiming that's a root. What does that mean? 3x equals 4. What are you going to divide by? 3x minus 4. All right, pretty simple. And again, this stuff is all written down for you. You need to work on that, though. You need to work. It's a lot of work. Yep, I did the work. All right, this one over here, let's take a look. Really kind of the same things. This is 4th degree, so they actually give me 2. What does that mean? X plus 2. That was easy. The other one is x equals 5/3. That's going to be 3x equals 5, and that means 3x minus 5. And then what are you going to do? Multiply that out, which would give you 3x squared. Minus 5x plus 6x is plus x, and you get minus 10. So what are you going to do? You're going to divide the polynomial by that, and you're going to get a depressed quadratic out of it. The depressed quadratic is pretty easy, but again, you need to work on that. We give you answers for a reason, by the way. We want you to check that. Another 4th degree polynomial, 2 roots are given to you. You get the idea. By the way, this one looks pretty interesting to me, and I'll tell you why. Looking at it, and you might be confused by this, by the way, but I kind of see this over here, and someone says, I don't know what I'm looking at over here. And by the way, you may not have an idea. And I want to point out the reason for that is, you know what? This may be very deceptive to you about what that is. And that's why it's so important you start looking carefully. Now, by the way, this one over here could also be incredibly deceptive. What they say, they said the roots were 4, so I do see that. I'm going to say, oh no, I don't see that. Let me see if I'm doing the right picture. Let's see if that right picture over here. Let me see if I got that. No, it's a different picture, but I'm sorry. This picture is 9x4, which is this one over here. Sorry about that. It's the wrong picture. So make sure you look at the right pictures, but that's all I'm saying. That's something I look at the wrong picture and I, that couldn't be right. I'm looking at the wrong picture. That's all there is to it. So over here, again, this is more difficult. Why is it more difficult? Whoops, I didn't mean to do that. I know I do it a lot. This is very abstract. All right, there's a parameter there, A. I would verify that they are actually roots of the problem. If they're roots, though, I want to point out, if minus 3a is a root, it means x plus 3a is a factor. And if 4a is a root, it means x minus 4a would be a factor. Multiply those two together and do your long division. And it'll work out pretty nicely. This one's also more abstract. You know, what are the roots? I want to point out what that means. They give me a 3rd degree polynomial over here, in x, by the way, and they tell me one of the roots is this. What do I do? X minus that number, which would be plus n plus 3. All right, let me write that down for you. Again, you'll see that divisor there. Yep, you got to divide. You have to divide. You'll find the other roots. Then you get to this thing about this sage business here. And it's a recurring theme. I'm sure you realize that by now. It's the sage. All right, what's sage? It's a computer algebra system, or CAS for short. It's open source software, so it's free to download. And we do recommend if you have a computer to download to, you download to that. Interactive web-based application, you can type that code in. But again, I can't say it enough times, our interest is in what Wells is presenting to you. And certainly I give you an answer key, and that's my work, by the way. If you see any errors in my work, please let me know that you believe there's an error in my work by emailing me. What work are we talking about? All the stuff that I'm putting down, including the graphs. If something's mislabeled or confusing, please let me know. Sometimes when I type things up, I don't do a very careful job of proofing it, and I might have made an error somewhere. And that's bad, because I'll be honest with you, that can confuse some students. That's why we're hoping some of the brighter students, when they're looking at this, can catch the errors and are willing to report the errors. Right? If you do report the errors, though, you'll be given credit for reporting the errors. All right? So I'm going to say, not bad. We got through that. It might have seemed a little difficult to you, but we did get through that, and we got to this section over here. Thank you for paying attention.